Hey there, we are the Study Buddies. In today's Mathematics Edition video, we'll be looking at the part 2 of Inequalities, which is a continuation from my previous video on inequalities. If you have not watched that video, do watch it. And also, we'll be looking at absolute values today. So rational inequalities are inequalities which have ratio, which means questions which involve fractions. So let us look at our first example. So, in rational inequalities, there's only one way which is very highly recommendable to use, which is the table method. So for just now quadratic inequalities, I mentioned that you can choose any one of them, but for rational inequalities, you have to use table method only, which is the most safest method. So let's move to our first example. 12 over x minus 1 is greater than or equal to 2x plus 3. So as what we do for all our inequalities, bring everything to the left hand side first. So 12 over x minus 1 is minus 2x plus 3 is greater than or equal to 0. So now make the denominators same, which is 12 minus 2x plus 3 times with x minus 1 over x minus 1 is greater than or equal to 0. So solve this quadratic equation and you will get 12 minus 2x squared minus 2x plus 3x minus 3 over x minus 1 greater than or equal to 0. So expand this and we are going to get negative 2x squared. So 3x minus 2x is x, so it's going to be negative x. So negative 3 times negative, it's going to be positive 3 plus 15 over x minus 1 is greater than or equal to 0. So as I have mentioned just now, the values of x in an inequality question should not have the value negative. So if we factorize this, we are going to get negative 2x squared plus x minus 15 over negative 1 minus x greater than or equal to 0. So we can just cut off the negative and we can factorize this whole equation. So once we factorize 2x squared plus x minus 15, we are going to get values of 2x minus 5, x plus 3 over x 1 minus x, which is greater than or equal to 0. So from this we can actually find out the values of x already, which is x is equal to 5 over 2, x is equal to negative 3 and x is equal to 1. So once we have find out the values individually for all the 3x, we can start building the intervals. So I would recommend to do the intervals earlier, right? So starting off with negative infinity, it moves to negative 3 first because it's the first negative value, and we have to put a closed interval because it's a equal to symbol over here. And for the next one is negative 3 to 1 open bracket. So you may wonder why I'm using an open bracket rather than a closed bracket, because usually when I explain, I say if there's an equal you have to put an closed bracket, and oddly now I'm using an open bracket. So why? The reason is simple. I'm using an open bracket because it is the denominator. So very important thing, whenever you take the value of x from the denominator of a question, it should be an open interval. Okay, so now let's move on. So after 1, it's going to be 1 to 5 over 2, and 5 over 2 should be a closed interval, and at last 5 over 2 to infinity open bracket. So using these 4 intervals, we will be doing the table method. So now I have completely drawn the whole table which we would be using for table method. So let's begin with our normal process of table method. So a number before negative 3, let's say we take negative 4 and we substitute inside this, and following that I'll choose 0 over here, and for this part I'll be choosing number 2, and for this part I'll be choosing number 3 because it's actually 2.5. okay, so let's substitute negative 4 inside this. So negative 4 times 2, you're going to get negative 8 minus 5, negative 13. So it's going to give a negative value. So for this part 0, so it's obviously negative value. So this part 2 times 2, 4, negative 5 plus 4, negative 1, again a negative value. and 3 times 2, 6 minus 5, 1, where you will get a positive value. Okay, so now let's move to the second row. Negative 4 plus 3, negative 1, again negative, 0, so it's going to be positive because you're going to get number 3 over there. Third one, 2 plus 3, 5, in which you're going to get positive again, and 3 plus 3, 6, again positive. So moving to the third row, 1 minus negative 4, which is 5, you'll get a positive value. 1 minus 0, you're going to get 1, again a positive value. 1 minus 2, you're going to get negative 1, negative value. 1 minus 3, negative 2, you're going to get a negative value again. So as what we did just now, multiply everything. So negative value times negative value, you're going to get a positive value. So positive times positive, you're going to get a positive value. Next, negative times positive, you're going to get a negative value, and again multiplying negative to positive, going to give you a negative value. Next one, negative value times positive value, negative times negative, positive value. Lastly, positive times positive, positive value, positive times negative, you're going to get a negative value. So now you already know all the 4 tiers, which means you already know the positive or negative value for each of the intervals. So once you've already known, you have to look at the question again, which is the one which I've written here, which is 2x minus 5, x plus 3 over 1 minus x is greater than or equal to 0. So as I've mentioned just now, if the value is greater than or equal to 0, we will be choosing the positive parts of the range. So positive and positive. So therefore these both ranges are going to be the answer, and therefore the answer for this question is going to be, so I'll write it down over here, answer is going to be infinity to negative 3 close bracket union 1 to positive 5 over 2 close bracket. Okay, so I'll write it 1 over 5 over 2 close bracket. Okay, so this is how we solve questions involving rational inequalities. So next, let's look at our second example. X squared minus 2x minus 10 over x minus 2 is lesser than or equal to 5 over x minus 2. So same, bring everything to the left hand side. So x squared minus 2x minus 10 minus 5 over x minus 2. So it's easy because both of the denominators are the same. So let's find out, factorize the upper part. So x squared minus 2x minus 15 over x minus 2 is lesser than or equal to 0. And after we factorize this, we are going to get x minus 5, x plus 3 over x minus 2 lesser than or equal to 0. So if it's lesser than or equal to, as mentioned before, we are going to choose the negative part of the equation. So let's find the intervals. First find the values of x, then following that, let's find the intervals. So x equals to 5, x equals to negative 3, x equals to 2. So we already know the values of x, and now let's find out the intervals. So it's going to start off with negative infinity to negative 3 first. So negative 3 would be a close bracket, followed by negative 3 to 2. 2 is going to be an open bracket because it's the denominator, followed by 2 to 5, 5 close bracket because it's on the numerator and it has an equal to symbol, and lastly 5 to positive infinity. So now let's resume with the table. So from negative 3 we are going to choose negative 4. So from here it's negative 2, the number before 2 is 1, number after 2 3, so 5, 4, after 5 I'm going to choose 6. Okay, so I'm going to find as usual one by one. So negative 4, negative 5, I'm going to get negative 9, so it's negative. Negative 2, negative 5, I'm going to get negative 7, which is also negative, just to double check. 1, if I substitute there, I'm also going to get negative 4, which is still negative. Then next 3 inside that equation, negative 5 plus 3, negative 2, again a negative. 6 minus 5, 1, positive. Okay, so negative 4 plus 3, negative 1, negative. So 1 plus 3, 4, 4 is a positive answer. So 4 plus 3, 7, 7 is also positive. And 6 plus 3, 9, 9 is also positive. So for the third row, negative 4 minus 2, negative 6, negative. 1 minus 2, negative 1, negative. 4 minus 2, 2, positive. 6 minus 2, 4, positive. So multiplying let's multiply each other. So negative times negative, positive, positive times negative is a negative value. So negative value times positive value is going to give a negative value. Negative times negative, this is a positive one. So positive times negative, it's going to give a negative value again. And lastly, all positive, and therefore we are going to get a positive value. Since we already have all the positive and negative values for each of the ranges, what we are going to do is that we are going to look at this symbol. So this symbol is saying the equation is lesser than or equal to 0. So if it is a lesser than or equal to, automatically we have to look at the negative part. So therefore the answer for this question is going to be negative infinity to negative 3, close bracket, union 2 to 5, open bracket. So that's all for this question, and therefore when you solve rational inequalities, you have to be a bit careful for careless mistakes and make sure you do everything correctly, and don't forget only table method is possible for this question. So now let's move on to absolute values. So basically how do we define absolute values is that they are defined as the real number distance from 0 to x. So let's assume that this is x. Okay, so this is what absolute values mean. So absolute values are usually denoted in the form of modulus x. Okay, so that's why we write an equation of y equals to modulus x, and modulus x is actually equals to the square root of x squared. So now you'll be looking at a few properties of absolute values. So here are the 7 properties of absolute values, but somehow I would not be explaining all the properties. I'll be explaining only properties 6 and 7. So for the other properties, I would request you to just remember the properties. So for this, when you see a modulus of x is lesser than any value, lesser than, or it can also be lesser than or equal to, it immediately becomes into this format where you get negative x and positive. So it means that x is in between of negative and positive, which means it's a graph of something like this. Okay, and unless if you see on the other hand modulus of x is greater than a, therefore it would become something like x is greater than negative a, or x is lesser than negative a, or x is greater than a, in which it means something like this. So don't worry, somehow to understand absolute values we would have to look at several examples. So let's look at this first example. Modulus of x minus 2 is equal to 3. So the first task in this question is that we have to remove this modulus and bring it to the right hand side. So when we remove the modulus, it becomes x minus 2 is equals to plus minus 3. So this is how modulus works. When you bring modulus from one side to the other side becomes a plus minus. So once you see a plus minus, what do? You have to split the equation into 2, which means you'll get x minus 2 is equals to 3, or x minus 2 is equal to negative 3. So x minus 2 equal to 3 is x equals to 3 plus 2, in which you're going to get 5, and x minus 2 equals to negative 3, which is negative 3 plus 2, in which you're going to get negative 1. Therefore, the answer for this question is going to be x equals to negative 1 or x equals to 5. So now let's look at our second example. Modulus of x plus 8 is equal to modulus of 2x plus 7. So now we have to bring the modulus from the left hand side to the right hand side, and also from the right hand side to the left hand side, which means this modulus would go here and this modulus would go here, causing both sides to have a plus minus symbol. So it's going to be positive negative x plus 8 equals to positive negative 2x plus 7. So in this case, now it gets a bit tricky, right? Like, because both sides have a positive negative symbol. So what do? We have to split again. We have to split this equation into two. But just for the sake of proving to you, I will show you both ways of splitting it. So one way, we assume that this is only a positive value. So which means you're going to get x plus 8 is equals to plus minus 2x plus 7. So on the other hand, we can also do it as 2x plus 7 equals to plus minus x plus 8. Okay? So when we look at this equation, we know that we can split this again because there's a positive and negative. So once we split, you're going to get x plus 8 equals to 2x plus 7, or x plus 8 equals to negative bracket 2x plus 7. So we'll solve both of them individually. So 2x minus x equals to 8 minus 7, in which you're going to get x equals to 1. And on the other hand, x plus 8 equals to negative 2x minus 7. Bringing the negative 2x here, we are going to get 2x plus x equals to negative 7 minus 8. 3x equals to negative 15, and therefore x is going to be negative 5. So this is one way of solving this. And let's say if I'm doing the other way, it's going to be, if I split this, it's going to get 2x plus 7 equals to x plus 8, or 2x plus 7 is equal to negative x plus 8. So I'll solve this side first, in which we are going to get 2x minus x equals to 8 minus 7. Again, x equals to 1, same. And for this side, it's going to be 2x plus x equals to negative 8 minus 7. 3x equals to negative 15, and therefore x is equal to negative 5. So if you notice properly, both these sides are giving the same answer. So when you see questions like this, choose either one, either this form or this form, provided at least one of them retains its positive negative symbol. Now let's take a look at our third example. So if you notice this example involves an inequality. So modulus of 3x plus 8 is lesser than 4. So according to the properties we have seen just now, if it's lesser than 4, immediately this equation would come in the form of negative 4 lesser than 3x plus 8, and 3x plus 8 is lesser than positive 4. So whenever you see they call this an inequality, an absolute value with an inequality, immediately change it to its corresponding format, so it would be easier for you to solve. So once you get it in this format, you have to split into two, as how we solve a normal inequality question. So when you split into two, you're going to get negative 4 is lesser than 3x plus 8, and on the other hand, you're going to get 4 is greater than 3x plus 8. So I'll solve this side first. So I'll bring everything to the right hand side, the left hand side, which is going to be 3x plus 8 plus 4 is greater than 0. So it's 3x plus 12 greater than 0. So 3x is going to be greater than negative 12, and therefore x is greater than negative 12 over 3, which is negative 4. Okay, so on the other hand, for this side, again do the same thing. We are going to solve it. So 3x plus 8 minus 4 is lesser than 0. So 3x plus 4 lesser than 0. 3x is lesser than negative 4. X is lesser than negative 4 over 3. So since we have got these both answers, we can combine it, and after we do a number line, we would get an answer. After we do a number line, we are going to get negative 4 over 3. So x is greater than negative 4, which means it's going to move somewhere here, and x is lesser than negative 4 over 3 is going to move somewhere here, and since it's an and, we are going to choose the middle part, and therefore the answer is going to be negative 4 over 3. So this is the answer for this question. So to know how to solve this part, I would recommend you to watch my previous video on inequalities. So now let's look at this example. Modulus of 2x minus 1 is greater than 2. So once we see a greater than symbol, we have to solve it in its corresponding method, where after we split, we are going to get 2x minus 1 is lesser than negative 2, or 2x minus 1 is greater than 2. Okay, so solve them individually. We are going to get 2x is lesser than negative 2 plus 1. So 2x is lesser than negative 1, and x is going to be lesser than negative 1 over 2. And for this side, 2x is going to be greater than 2 plus 1. So 2x is going to be greater than 3. X is greater than 3 over 2. Okay, so that would be the answer, and therefore the answer would be x is lesser than negative 1 over 2 union x is greater than 3 over 2. Or to explain it in interval format, it's going to be negative infinity to negative 1 over 2 open bracket union 3 over 2 to positive infinity. So since it's an or over here, we have to use union. So now let's look at our last example. Modulus of 4x plus 3 is greater than modulus of x plus 4. So since we see both sides are having modulus and they are in an inequality, how we are going to solve this is a bit unique, where we have to power 2 the whole equation. So once we square this whole equation, it's going to be 4x plus 3 square greater than x plus 4 square. So when we square this, we are going to get 16x square plus 24x plus 9 greater than x square plus 8x plus 16. Okay, so now we bring everything to the left hand side, in which we are going to get 15x square plus 16x minus 7 greater than 0. So when we solve this, once we see this, we have to remember, if you watch my previous video, you would know how to solve quadratic inequality. So this is a quadratic inequality scenario, and we would have to solve it in its method accordingly. So 15x square plus 16x minus 7 equals to 0. We would get an answer of 5x plus 7 and 3x minus 1 equals to 0, which means x is equals to negative 7 over 5, or x is equal to 1 over 3. So for now, I would prefer using graph method. So I would draw a graph. So since the a is positive, the graph is smiling, and I would put 2 points, negative 7 over 5 and 1 over 3. So in this case, we can see that the equation is greater than 0. So therefore, I would be shading the parts which are positive, and therefore the answer is x is lesser than negative 7 over 5, or x is greater than 1 over 3. Or to write it in interval forms, it's going to be negative infinity to negative 7 over 5 union 1 over 3 to positive infinity. So this is how we solve questions which have two modulus and an inequality. And so that's all for this video, guys. If you like this video, do like this video, comment if you have any doubts, share this video to your friends, and don't forget to subscribe and click the bell icon. That's all for today. Thank you, take care, goodbye.